Hello, everyone, and welcome to day four of Cloud Native Sustainability Week. And I know it seems kind of weird because my partner in crime, Sayam, is not here today. He is unfortunately out because of some personal emergencies. But don't worry, y'all are in safe hands. And we will ensure that things go as planned. But for those who are joining new and who have no idea of what this whole gig is about, um, Cloud Native Computing Foundation, that is the CNCF, is essentially um, hosting Cloud Native Sustainability Week all throughout the second week of October, which is right now. And what we're doing as part of this week is bringing on folks who are working in various areas of sustainability and spreading awareness around how you can um, leverage different tools, technologies, software, hardware to actually, have a more sustainable approach to technology. um, as Sayam would have recapped if he had been here, the first thing that we normally, the first day that we had was with Henrik from, talking about Cube Green and Kepler and how he integrated it together to develop a full-fledged solution that could generate meaningful insights um, into the kind of workloads that were hosted on cloud native, and how you could leverage those insights to better the sustainability performance rather of those workloads. Second day we had Mark from Deep Green, who spoke at length about data furnaces and how they are going to be the future, because as we all know, the number of data centers isn't fortunately or unfortunately going to go down. So we could put the heat or the um, heat generated from these data furnaces to better use. So that was day two. And day three was, of course, yesterday with the Vesha CEO, Raj, who spoke at length about, their smart scaler product. Now, smart scaler as a product is not, is not available to use right now. But Avesha and Raj yesterday essentially told us that they do plan to, throw it open to the public in future for um, you know use, and probably use it like an ops GPT, if I can quote Raj from his session yesterday. But today I am gonna have an interesting perspective to all of this, and bring on David from Expanso. So David, hello there, and welcome to Sustainability Week Day 4 of the live stream.
Thank
So
you
how
so
are
much
you
for
doing
having me.
today?
It's extremely exciting to be here.
And do you want to tell your audience, our audience rather, do you want to give a bit of an introduction about yourself?
Yeah, of
And
course.
yeah.
So, excuse me. I am Dave Aronchick. I am CEO of Expanso, and I had gotten started down this path, towards a much greener and sustainable future in really 2015. I was the first non-founding PM for Kubernetes. I led that for 3 years. Led PM for them for 3 years on behalf of Google. Um, I also started an open source machine learning project called Kubeflow, which has been very successful. And both of those, they had, I mean, my desire to make this work had sustainability at its core. It's basically both of them had this idea that, boy, there's a lot of machines out there. They're very distributed in these different requirements in green domains, in energy domains, in usage, utility, things like that. How do we make maximum usage of them in all of these various ways? And so that was the idea behind both of those platforms. Now, obviously, those platforms did other things as well, but I then went to work at Azure and in the office of the CTO on some of their early OpenAI work and some other ML activities. And now finally I've come to start this company. And I realized each of those areas had elements that overlap with what we're doing right now. And what we're doing right now is basically taking a lot of those concepts, focusing on where the problem is, where the data is, where the green is, whatever it might be, reusing the existing stuff as it stands, and then turning it into something valuable. And I think that that's, my underlying thing about this sustainability world is the answers are already there. The resources are already there in so many ways. And it's just a matter of us reusing and making maximal use of them rather than what we're doing right now, which is a lot of waste. So that's the broad strokes of what we're doing. I'll walk you through, a quick slide here. Can I do that? Oh, there we are. Great. Thank you. Like I said, the company name is Expanso. The open source project, and it is available for open source right now. You can go out and get it. It's let me join the chat here. Can I type or connect to the comment?
Yeah,
Sorry,
absolutely.
I haven't used this before. I apologize. My fault.
If
Yeah.
you're talking about the Bacalhau project,
There we
I
are.
can
There we are.
definitely link. Yeah, I
Yep,
can
there you go.
definitely link to it, so you don't need to worry about it.
Okay.
I'm
Oh,
definitely going to
terrific.
do that.
Thank you.
Yeah.
So the high level is, yes, we're running on what the Bacalhau project. That's the open source project. It is completely open source. You can download it, compile it, and so on. The binaries are commercial, but like I said, it's completely open source and you can do whatever you like. But the problem that we're really trying to get to here is solve for what you see there. People spend too much on data, right? They spend too much money. That's moving it around, storing it, putting it in a lake. They spend too much time, moving it over these networks is slow. Getting answers is slow. Compute is often underutilized, so on and so forth. And it's too much risk. Moving things across latency boundaries, across geographic boundaries, often is a security concern. It's often a regulatory concern, and most importantly, it's also an environmental concern. You're moving things from, for example, area A where they may be entirely renewable into something that's all coal powered. And again, this is something that people should have an option to do, but we don't give people platforms that make it easy to be thoughtful about that. And that's very much what we're trying to do with Bacalhau. So with Bacalhau, our overall thing is, maximize your data value, reduce the data cost, lower the transition costs, transfer costs, resources, et cetera, process faster. That means, machines are simply not up as much using electricity and so on, and improve your security. And we like to say your enterprise already operates worldwide. Your infrastructure should too. So people often ask, what was the idea behind this? How'd you get started? It really was this. I and the team that put it together had this idea about distributed computation. We certainly knew Kubernetes inside and out. We knew all these various platforms out there. And our question was, could we do the same that Kubernetes did inside a single data center, but extend it to outside a data center? Now, again, I say this as someone who loves Kubernetes deeply, right? This is not remotely a replacement for it. Kubernetes is wonderful inside a single zone. But the second as you know, you cross zones, you cross regions, you cross clouds, et cetera, that's where Kubernetes begins to misbehave. and you have to come up with an entire new orchestration system so that you can get your job to the place where Kubernetes needs to execute. And we wanted to do that where it was built for a focus on distributed data, because that's the reason you would do it, right? Your stream is over there, your log is over there, your images are over there. Let's move. People ask often, how did you come up with the name? We were in Portugal actually when we came up with this idea, and we kept calling it compute over data. And it turns out that when you keep abbreviating COD, the Portuguese word for COD is Bacalhau, and that's how we came up with the name and our logo and all that kind of good stuff. So what we want to do with Bacalhau is solve for these three big areas. One, can we make it smarter in how you transform your data before you move? And this, again, this is probably one of the biggest things that, it affects sustainability. People spin up things in US East, not because they like it, but because it's easy. And, then once you spin up one thing, you want to spin up more things there because the data is right next to each other. Scheduling is really easy, so on and so forth. Could we make it as easy to spread that same functionality in a variety of locations, and so you can be more efficient? Second is around poor networking. As you know, once you cross outside of a single zone, you start to run into poor networking. Now, it's not saying network providers are like being shitty. It's like simply speed of light problems and natural errors that occur as you go over long wires and things like that. You need a system that supports that as well. And then finally, using data in isolation. Many times you don't want the data to ever move. How do you have a system that supports that? And our goal is for Bacalhau to solve all three. So to start, before Bacalhau, you might have a node out there that has all kinds of various data on it. It might have logs, images, video, text, whatever it might be. And you would typically take that log that was generating or collecting the data and move it into these central clusters. Now, again, that's fine, except you do run into quite a few issues here. Bandwidth, removing PII, sanitizing the data, consistency, data ordering, et cetera, et cetera. And for the purposes of this call, for all of you that care, oftentimes this could be very green and low power, and these could be very, brown and using a lot of energy. But you don't need to do a lot of this, right? You want to do some basic functionality over there. And of course, you don't just want to do it on one machine. You want to do it on many machines, right? All of them that are spread all over the world. And when you look at, okay, I want to do it from just these 5 machines and I want to move that all in, that can be quite a lot of data now that you're moving as well. So it just kind of like compounds on top of compounds. The idea behind Bacalhau is that you have this Bacalhau network. On each of these remote nodes, you run a very small agent, and then you schedule against the network. And you say, hey, you know what? Bacalhau node, would like to schedule against just these 5 green nodes to do this job. And Bacalhau will find those nodes out there in your network, schedule those jobs, move the Docker container that you wanted to execute over there, run on it locally, and then move only the results, not the big things, back. And so it becomes a much more efficient way to engage in all these very distributed systems without having to overcome, is this machine up? Is this machine the right format? Is this machine green? So on and so forth. You just apply labels and we take care of the rest. So in summary, in this case, Bacalhau reduces the challenge of transforming that data before you move it. But again, we can do a lot of other things. One thing that we're already seeing people do is use us for doing running ML jobs. So you take your model and you actually push it out there to those green locations and run it in all of these places. The second is executing over unreliable networking. Before Bacalhau, you may want to deploy on a global network or across cloud or one of these areas over here, or like a vehicle or something like that. Again, if the thing is live, it's not the hardest thing in the world, but it's not easy either. Because, these things could appear, disappear, like they show up, they don't show up. this is the very challenge of doing global networking. How do you deal with all of these things? And this is something that, again, we handle in a first class way. With Bacalhau, you submit your job to the network, and the moment these things become available, then Bacalhau will schedule it and move it over that unreliable networking. Um, and so at the end of the day, it's super powerful. But you, as a data scientist or developer, don't have to change your layout at all. You're simply using this tool to abstract yourself from what can be some of the complicated interconnectivity. A summary for this one is, we excel at scheduling, executing jobs over unreliable networks. That's really our goal here. Sorry, I've been talking. Are there any questions? I'm happy to kind of like pause for a moment. Otherwise, I can keep going.
Not at the moment. No. We can continue with the presentation, and maybe people might have questions around it later on. But I had a question. Are we going to delve into how Bacalhau achieves all of this, like a brief architecture or something of it, or are we just like skimming through the top? I just wanted to
We're
understand.
skimming over the top, but I'm happy to show you a super brief architecture for sure.
Yeah, I mean, that would be helpful for folks who, are tuning in to understand like what exactly and how exactly all of this is achieved once
Yeah, for
we
sure.
get done with this show. Yeah,
Yeah. Well, let me show you that real quick. How do I will. Why don't I just share my screen? That's probably easier.
sure.
So this is the high level architecture. I'm
Just
happy
a
to go
second.
as deep as you would like, and this is all out on our documentation as well. As a user, you can submit to any, via any of these, the CLI, the API, the UI, or a hosted dashboard. That submits to a global endpoint. Now, you don't know where that global endpoint is necessarily. You can specify one, but you're just basically talking to the entire network inside of each latency domain. So, like on a ship or inside of AWS and on Google Cloud and on prem or whatever, the network will by itself spin up what we call a local scheduler. So, the global API endpoint will say, hey, who is a good fit for this? A local scheduler will say, oh, I know about a node that is a good fit for the job you just described. Come schedule it to me. And then that local scheduler will take the job and push it to the node, and then the node will go and execute the job. Now, the reason this works so well over these distributed networks is typically when you talk about Kubernetes, you'll only have that central, Kubernetes master as an API server as the center
Sure.
point. So you won't have this concept of broken up and eventually consistent local schedulers. They will have to have consistent heartbeat connection to each of those nodes. And so if you run into networking issues or things like that, then you run into problems. Does that make sense?
Yes. Just a quick question. Are there any specific hardware requirements? Because um, you know, given that we are not going to have like as we move towards the edge, we're not really going to have like a all of them with a x86 64 chip, but we might have an arm or maybe a different sort of architecture. Are there like any specific architectural requirements for the project to run on?
No, not at all. We support, so the agent is very small. I believe it's maybe 70 megabytes in total. And if that's too big, let us know. We can, create a small build, a smaller build. But the agent doesn't do the job running. The agent hands it off to a local binary to do the
Right.
job running. And that local binary, we support Wasm and Docker in the box. You can
Okay.
also add with just a YAML file, you can add any local executor you like. So if you're like, hey, you know what, I don't want either of those, the
Hmm.
binary that I want to execute is already there. It's already compiled for the architecture I care about. We will
Okay.
take that and execute according to your OS, and we support Windows and Mac and Linux. We will execute according to your OS the binary that you want. And then you say, okay, I want it, here's my custom jar file or whatever. Here's the Java command, here's the jar file, go execute this when you get a job, and we can do that as well. So very, very fluid in what you support. And like I said, the agent is very, very low cost you probably won't even notice it on your total CPU usage most of the time.
Ah, okay. That sounds cool though.
Yes.
Um, and are there any other, um, limitations or any prerequisites that users need to be aware of with respect to when you're running like ML workloads or something like that?
Yeah.
Any CPU, GPU requirements? Because that's a question we get anytime we speak
Yeah.
about
Yeah.
like
Yeah.
ML workloads. Yeah.
It
So
again, it totally depends on you, on the model you want to run. We have run 2 billion parameter models on this. We've run stable diffusion. We've run, I mean, take your pick. The caveat is always based on the model. You're going to have to the node that this runs on will have to have that amount of compute.
okay.
Interestingly, it's usually the reverse. It's like, how small can we make the model and still get the performance? And obviously, you should go use a framework that does quantization like OctoML and things like that to reduce the size of your models in order to fit them in. But it's not going to be Bacalhau that determines it. It's basically what kind of functionality, what kind of performance, and so on that you'll want. Now, that said, there is a big caveat here, and that is when it comes to all jobs here need to be thought about as embarrassingly parallel. So you almost it's not that the network doesn't support it, but it's not going to be anywhere near as performant if this node needs to talk to a node that's over here in this other section. You can do it, but we highly recommend against it. What you want to do is here, when you're submitting the job, you want to think about how to shard your job in a meaningful way and say, oh, okay, I want every node in the network to handle whatever, 1,000 1,000 images, for example, and then split it up and go. And then what you do is you say, okay, well, I have 10,000 I have 10,000 images. I have 1,000 images per job. So I'm going to split it up myself into 10 jobs. And during that time, I'm not going to have any of those things talk to each other. When each one is done, I'll collect all the results and do something with it. So that's the way it would work. And the reason is because, there's no commitment here as part of your network about what the various connectivity is between the nodes. If you are doing something that requires high connectivity, I would strongly recommend, having the local schedule then talk to a local Kubernetes cluster or some other distributed system on-prem, and you can still get this kind of like global scheduling, but break it up in that way. Does that make sense?
Sure. Yeah.
Cool.
Do you want to switch back to the slides that
Yes,
you were
absolutely.
presenting? Yeah. Sure.
So, so that's number two. Number three is using data in isolation. So a lot of times, especially let's talk, ML wise, you'll have a situation where you, want to have a center of excellence around your centralized orchestrator. And it will want to talk to individual, labs or organizations or things like that. The labs can't talk to each other due to regulation, but oftentimes, even the center of excellence isn't allowed to have unlimited access to these particular machines. And you'll need an audit log to show regulators that you aren't, in fact, pushing it back and forth. So with Bacalhau, what you do is you set up nodes in each of these locations, and then you schedule through Bacalhau. The jobs all take place entirely on-prem, and nothing is moved back at all. And by doing that, you can now show to the regulator an audit log saying, hey, here you go. Here's the entire list of things. Nothing ever moved, and we, maintained regulation according to, what's required by law. So those are the three big areas that we see people using Bacalhau already. As I mentioned, this is very high degree of overlap with sustainability and other things, because you can make decisions about where to run jobs, how to execute, and so on. And one of the things that we are finishing just this quarter is the ability to name your nodes based on local, energy awareness. There are things called watt, like there are services called watt time and so on, where you can say, okay, this node is running at 2 o'clock in the afternoon in whatever the UK. This is mostly a wind powered node. It gets a 93 value for green. This one is running on a nighttime node in Poland, which is mostly coal. It gets a 22% green or whatever it is, and then you can schedule across your entire network and say, I would like to schedule to just the green nodes, and that's something that you can do. That's something that we are working on this very quarter. On top of that, like I said, that run on green is coming soon. Better resilience for edge scenarios, daemon jobs that sit there and run forever, not just batch jobs, as well as some authorization and data catalogs and so on and so forth. Or better yet, come tell us. You can see our Slack. You can see our we're online almost constantly. We would love to engage and talk further. The team, we are a funded company. Even though this is an open source project, it is a funded company. We are happy to support you in your various organizations and so on and so forth. If you need commercial support or an SLA, please come talk to us. We also have a public network that's out there, and we've had more than 1.2 million jobs executed against us on the public network, which is really exciting. A lot of people doing interesting things on it, and we would love to do it. Some sample use cases, and then I'll shut up and we can talk further. Log management, ML training, ML inference, doing a distributed data warehouse. Oh, I have whatever log files across 400 different machines. Show me the 6 last error messages I got, or something like that. That's something we can do for you. Fleet management, things like VMs, devices, services, processing over data in geographically distributed locations. You have stuff on a NAS, you have stuff on an S3 bucket or whatever in a region, and you want to do something against that. That's something we can provide for you without having to centralize it first or provide SSH access. Unreliable, network connections and federated learning. These are all things that we support right now out of the box, and we'll be having some public use cases around them coming shortly. And that's everything. I'm happy to chat further. I'm happy to, I don't know, show you what it's like to execute against the public Bacalhau network. I don't know. You tell me.
Um, a demo, sorry, a demo would be great if that's a possibility, because like you said, it would like further cement the idea in people's minds about what Bacalhau can do, and especially if you have like something publicly available, that'd be great.
For sure. So let's switch over here to
The other one,
I will share my screen. Yeah, can you just grab the screen?
this one,
Yep, that's the one.
yeah, sure.
And can you see my what do you call it here? My terminal.
No, I can only just see your. I can just see the slideshow currently. Yeah.
Okay, let's do this. All right. So we'll start here. You can go to any one of our websites, and why did this go in this color here? Did we turn off night mode? That's super annoying. Anyhow, we have a ton of examples that you can see here out there and running. To get started, it's really, really straightforward. You just pick, a standard job. We'll do a really basic one, like I want to run a job from a from a URL. So actually, let's do an even easier one. There's my quick start. So if I want to just do a very, very basic job, you first you install Bacalhau, and to do that, you can see that here. I actually just did it earlier this morning because we had an update. You do here curl-s l and then this and then bash. The instructions are all on our public website. You can see that here and so on. Really, really straightforward to get started. Just click through the to the GitHub repo. And you can see in our Bacalhau repo here, the README shows you how to get started. Here's how to do the installation, very straightforward. And then, if I say, here, um, Bacalhau run, hello sustainability. Oh, uh-oh. Oh, that must be an old one. Sorry. Shows you is really a live demo. Okay. All right, we are connected. Great. So off you go. You can see here our various things, and when I go here and I say hello sustainability, what this is doing is it's doing a Docker run, and then it chooses a base image, and you can have an entire URL, or you can have something else. Then you say echo, and so this is the command that's running inside this container. And what it's going to do is it's going to print out to standard out hello sustainability. And in order to get the results, I can just do that here. And I'm going to get the results of this job where I download. So it's actually going to go and fetch the results themselves. I don't know why it's taking so long. Did I misconfigure something? All right, I'll have to figure that out. Sorry, I don't know what's going on there, but I can see this by just doing a describe. So here's the entire job. This is a description of the job with all the API and other information, and you can see here it ran it. Here was the image. It said here were the parameters: echo, hello, sustainability. And then when I go down here and I see what the standard out is, I can do this. So pretty straightforward stuff. If I want to do some more advanced things, I can go back over here, and there is a lot more that you can do. Like I said, if I go and I want to run, grab something from a URL and run it, I can do that here. This will output the job. Oops. Sorry. So what this is doing, this is now for my job. It will download this image to the node that I just put it on. It does a very straightforward download. So I don't have to have the data already there. I could move it around if I'd like. And you can see all the states of my jobs and so on. It's very similar to the overall Kubernetes network. Let's just do that. That's not what you wanted. You can see the job there. It was completed properly, and so on and so forth. So, this is what the broad strokes of it are. This is the public network, but most folks are not executing on a public network. Most folks are executing privately over their own private data, over their own shards, or things like that. But the net of it is that, it really is this simple to get started. If I wanted to run a Bacalhau node on my current machine, it is this simple. I am now running one right now. There's nothing more to this. And if I wanted to, for example, start a second node for the cluster, here I go over to a new terminal, and it's not going to work because I am trying to get it under the same IP address or a same port, which is now going to conflict because I'm on the same machine. But you get the idea. Does this all make sense?
Yeah, it does. I mean, that at least solidified it in my head. But yeah, I don't see any questions. I'm not really sure about the audience. If they're getting confused, or if they're even more um they're understanding it better. But I think this is pretty solid, given that you are also leveraging WebAssembly. That I think adds to another layer of
Absolutely.
from the sustainability perspective, and even from uh, you know like we were talking when we were talking with Mark the other day, we were talking about how it needs to be a stack layer, right? Like you cannot approach sustainability just from one angle. You need for it to be like from multiple angles. And I think like even the fact that the y'all are supporting WebAssembly workloads is another layer that is added to all of the stuff that you just spoke about in the presentation.
Yeah, like I said, I should have mentioned we support Docker and Wasm out of the box, like I said, and for us, it really is about some of the details on how we make it work for your particular problems. So yeah, just tell us if you see sustainability options or you see things like this. We would love to figure out how to make it work in a better way. You tell us.
Absolutely. And I think as folks dig deeper into the project, they'll probably get more insight into the kind of, prowess that your project can bring to their workloads. Because obviously trying a hands-on demo or trying it locally always adds that touch of understanding it better. At least it does for me. So I'm not sure about the others, but I'm definitely one of those who needs to like tinker with stuff before fully understanding a project. But yeah, this was great, and I really think I learned a lot from the stream if nobody else did. But I definitely learned a lot, and I really um, was very intrigued by the spoke previously at WasmCon.
Yeah,
And yeah, and I was really looking forward to actually exploring a lot more, but didn't get the chance to in the interim. But this was a great beginner level introduction to what Bacalhau can achieve, and I'm hoping to dig into it and probably get back to you with some of my feedback.
absolutely. I would love that. Like I said, please do let me know if anyone is out there. I'm also happy to just hang around and talk sustainability. It's a super big area of passion of mine. If you have data sets you would like to make available in a sustainable way, if you have workloads that somehow help with sustainability, I want to help contribute to that. If you have highly distributed systems that potentially are trying to make your organizations more sustainable, come talk to us. We would love that.
Absolutely. And we will be including, where you can reach out. I mean, I know you've already mentioned it in your slides, but whoever, could not, like, this is also up as a recording on YouTube. But if you're not able to catch that, we will be adding, further links in the description about where you can catch David and, the Bacalhau project off the stream. And, probably you can get in touch with them over the community Discord or on GitHub or wherever. So I guess since there are no impending questions, I think we can call it a day. But I really, really would like to thank you, David, for
It's my
coming
pleasure.
on.
If,
Yeah,
like I
and
said, please don't hesitate. Please reach out, even if it's something crazy. Anyone on here, I could not be more passionate about sustainability. So if there's something I can do, let me know.
absolutely, absolutely. So that's it for today, and we'll be back to regular programming hopefully tomorrow. But Siam on here, and we'll be recapping what we learned throughout the week, including today, because Siam's not exempt from watching this video and learning what David has had to say during the video. So we're gonna be recapping this video along with whatever we've learned over the week tomorrow. And yeah, I am hoping to catch whoever is going to tune in tomorrow at the same time, that is 8:30 a.m. PST. And hopefully, yeah, we will see what surprises are in for us tomorrow. And with that, I think we'll call it a day.
Thank you so
So
much.
thank you everyone, and have a great eve or great day ahead. See you.